Alright everyone, in this video I'm going to discuss rearranging and manipulating algebraic equations. And when you study economics, you'll see that very often we do need to rearrange our algebraic formula in order to help us find various solutions or to see the implications of different conditions. To take an example, let's look at the following two equations which describe actually the same demand relationship, and they differ only in which variable is being modelled as the dependent variable. So equation 2 is actually equal to equation 1, except we've moved the price variable to the left-hand side. This is often called an inverse demand equation because it does model price as a function of quantity demanded instead of quantity demanded as a function of price. And we do often need to have our demand in its inverse form. So this is actually a pretty good example from economics where we do need to move from, equation 1 to equation 2 or from equation 2 back to equation 1. Now, to this skill of the manipulation and rearrangement of our equations, really my most useful advice is to consider the maxim, whatever you do to one side of the equality, do to the other. Now, this essentially treats the equality sign in our equations with the utmost respect. For instance, let's consider the following equation: x plus 7 is equal to 64 plus y. So the equality here means that the value of what is on the left-hand side of the equation, for instance, it's exactly the same. It's equal to the value of what is on the right-hand side. And just to kind of give an illustration, we can think of some scales where we might be weighing goods or things. And for the scales to be level, it means that the weight on the left-hand side scale is equal to the weight on the right-hand side. And it's the same with our equality. When our equality holds, the stuff that's on the left-hand side, x plus 7, it's the same value, the same weight as the stuff on the right-hand side, 64 plus y. And that means that if we were going to do something like if we added 5 to one side of the equation, well, in order to preserve the equality, in order to keep those weights level, we would have to make sure that we add 5 to the right-hand side as well. So if we did that to our equation, we would get x plus 7 plus 5 is equal to 64 plus y plus 5. And just adding those terms up, that would be, well, x plus 7 plus 5 is 12 is equal to 69. That's 64 plus 5 plus y. So we have created this new equation, but it's completely legitimate because we've been careful about how we operated to both sides and we made sure that we preserved that equality. So when we were working with our equations then, if we are in a situation where we need to rearrange or manipulate our equations, we can operate on one side of an equality in whatever way we want. We just need to make sure that if we're changing the value of one side of the equation, we need to apply the same operation to the other side in order to preserve that equality. We need to make sure the scales are kept level. Now, the next thing to remember, or just to know, is what we call inverse operations. So operations are said to be inverse if they undo one another. Now, the big ones to know for the moment are addition undoes subtraction and subtraction undoes addition. So, for instance, if we had like 5 and we subtracted 5, that would be equal to 0. If we wanted to undo that subtraction, if we wanted to get back to our original 5, from 0, we would add 5. 0 plus 5 is equal to 5. So the addition here has undone the subtraction. We've gotten back to our original number. And likewise, if we had 5 and we added 5, we would get, 10. 5 plus 5 is equal to 10. In order to undo that addition, we would just subtract 5 again. So 10 minus 5 is 5. So our subtraction has undone the addition. All right, now our next two kind of operations we have to think about is multiplication and division. So multiplication undoes division and division undoes multiplication. So if I had, for instance, 5 and I divided 5 by 5, that's equal to 1. In order to get back to 5, we would multiply 1 by 5, that's equal to 5. So our multiplication has undone the division. And if we had a multiplication, say we did 5 times 5, that's equal to 25. In order to get back to 5, to undo that multiplication, we would divide 25 by 5. We would get back to 5. So addition is the inverse of subtraction and multiplication is the inverse of division. These operations undo one another. Okay, let's do an example then. And let's consider deriving equation 2, we saw that before, from equation 1. So I'm starting with our demand equation. Quantity demanded is equal to 12 minus P on 3. And I want to end up with the price variable on the left-hand side. So at each step, what I'm going to think about is about moving the price variables to the left-hand side and moving the quantity variable to the right-hand side. But I'm going to remember whatever I do, I have to apply that operation to both sides of the equality in order to preserve that equality if the operation changes the value. So here's one way I could do it. Well, see that negative P over 3, that's a minus P over 3. To undo that minus P over 3, I could plus P over 3. Addition undoes subtraction, if you remember. But I would have to make sure I do it to both sides in order to preserve that equality. So I get quantity demanded plus P over 3 is equal to 12 minus P over 3 plus P over 3. The minus P over 3 and the plus P over 3 cancel out. Now, the next thing I could do is move the quantity variable to the right-hand side. So I would subtract it from the left-hand side and I would also subtract it from the right-hand side. That gets rid of it on the left-hand side. Those quantity variables cancel out. And now I have my quantity on the right-hand side, which is what I wanted. All right, I'm left with P over 3 is equal to 12 minus quantity. Now I have a division by 3 here, which I want to undo. That's on the left-hand side. So multiplication undoes division. So I'm going to multiply the left-hand side by 3, and I'm going to multiply the right-hand side by 3 as well. So on the left-hand side, the 3's cancel out. On the right-hand side, I can open up those brackets. I've multiplied everything there by 3, right? 3 times 12 is 36. And 3 times that negative quantity demanded is minus 3 quantity demanded. And that's it. We have derived equation 2 from equation 1. All right, let's do another example. Let's say that I had y is equal to cy plus I plus g plus x minus m. And let's say that I need to solve for y. So when I'm being asked to solve for y, I'm being asked to isolate y on the left-hand side of our equality and see what y is equal to. And you might see something like this if you're doing macroeconomics. And you can see the problem here is that I've got y on the left and the right-hand side of our equality. So what I'm going to do is that I want that cy term, I don't want it on the right-hand side. I want to remove it. So I'm going to take away cy from both sides. That will remove that y from the right-hand side and it will put all the y terms on the left-hand side. The positive cy and the minus cy cancel out on the right-hand side. Now on the left-hand side, the next thing I'm going to do is factor out y. So I take y out and I open some brackets, and what am I left with? Well, y divided by y is 1, and negative yc divided by y is negative c. I can close the brackets. Now factoring out doesn't change the value of what's on the left-hand side here, so I don't need to do anything to the right-hand side. I can then, however, I've got y multiplied by 1 minus c. I can divide both sides by 1 minus c to isolate that y. And actually I get then our solution, y is equal to I plus g plus x minus m divided by 1 minus c. And that's our solution. And that's how I approach manipulating and rearranging our algebraic equations. There are 2 things to remember here. Firstly, respect that equality. Whatever we do to one side of the equality, whatever operation we perform on it, if we are changing the value of what's happening in what we're doing, we need to do the same thing to the other side to preserve the equality. Secondly, let's remember our inverse operations. That helps us undo operations in order to isolate variables or solve for different things, whatever we need to do. All right, I hope that these videos are helpful for you. If you would like written notes to help you on your journey, or even just to support this channel to help me make more videos, you can visit my store. There's notes there on basic math skills for economic students. The notes include lots of practice questions and solutions as well, which can help you solidify your understanding of the skills discussed in these videos. If these videos have helped, also please like and subscribe, comment below, share, all of that. It all helps. Any feedback is also welcome. Thank you everyone for watching my content. I'm sorry about the voice. I do have a bit of a cold. Hope you guys are doing well.